Alright, number 1. Given the vertices, we want to determine the quadrilateral's most specific classification. So A, B, C, D is what we're given, and it is in order. I'm just going to draw it so we can visually see it. A, B, C, D. The first thing we need to do to make sure that we're doing this correctly is that we need to make sure that all the sides are equal, or we only have two sides that are equal. So the way we're going to do that is we're going to compare A, B. A is at 4, -4, I believe. Let me just make sure I wrote that right. No, it's 9, -4. It's 9, -4. And then B is at 8, -2. So for us to do it, we're going to be using the distance formula, which states it's x2 minus x1 squared plus y2 minus y1 squared. So I'm going to label these x1, y1, x2, y2. To the distance formula right here, distance is equal to 8 minus 9 squared plus -2 plus 4 squared. We get the square root of -1 squared plus positive 2 squared. So we get the answer is, as a square root, it would be 1 plus 4, square root 5. Now we're going to do BC. So BC, we have B is at 8, -2. And then we have C, which is at 2, -5. Label our subscripts x1, y1, x2, y2. So we have distance will be equal to the square root of 2 minus 8 squared plus -5 plus 2 squared, which is equal to the square root of -6 squared plus -3 squared, which is equal to 36 plus 9, which will be 45. Square root 45. Now we're going to be working with the realm of C to D. So CD. C is at 2, -5, and D is at 3, -7. C is at x1, y1, x2, y2, and then from here distance is equal to the square root of 3 minus 2 squared plus -7 plus 5 squared, which is equal to 1 squared plus -2 squared, which is equal to 1 plus 4 square root 5. Then lastly we have DC, or DA, and DA, D is at 3, -7, and A is at 9, -4, x1, y1, x2, y2. Distance is equal to 9 minus 3 squared plus -4 plus 7 squared. So here you get it as 6 squared plus 7 minus 4 would be 3 squared. Here you get 6 times 6 will be 36, 9, 45. Alright, as you can see we have 45, and we have square root 5, square root 5. So right away we can see we have two different sides. So the only type of quadrilaterals we can have at this point is either a rectangle or a parallelogram. Can't be a rhombus because all the sides need to be equal, and it can't be a square because all sides need to be equal. So it's either a rectangle or a parallelogram. If it's a rectangle, the diagonals are going to be equal. And if it's parallelogram, diagonals are not equal. Alright? So that means we're going to be doing AC and BD. So here we have AC. And then on the other side we have BD. A is at 9, -4. And then C is at 2, -5. B is at 8, -2. And D is at 3, -7. So I'm going to move this over. I'm going to move it up. Alright, so we're going to do x1, y1, x2, y2, x1, y1, x2, y2. Use the distance formula. Distance is equal to 2 minus 9 squared plus -5 plus 4 squared, which is equal to the square root of -7 squared plus -1 squared, which will be equal to 49 plus 1 will be square root 50. So we have square root 50 right now. And let's see what happens here. D is equal to the square root of, we have 3 minus 8 squared plus -7 plus 2 squared, which is equal to the square root of 3 minus 5 would be -5 squared plus -7 plus 2 would be -5 squared, which would give us square root 25 plus 25 square root 50. So, right here, both of these are equal. So, it has to be the diagonals where they're equal. So the only answer here would be a rectangle. So, what we have, ABCD, is a rectangle. Okay, that's our answer for number 1.